plug it, right? Oh, you need me to approve it? Yeah, I was gonna do that once you. Okay. So Matt's gonna do a live demo, which we don't usually do. So just to make this easier on your eyes, I posted a meet link on this page for this meetup. If you want the actual code, it's APU hyphen, or let me paste it somewhere. So this is the QR code for the Google Meet. I think it's bigger. So you can open this on your phone or your laptop, and then you can actually see some of the text in his live demo. So just go ahead, join. I'm going to start admitting people right now. So I think Matt's there. And when you join, just turn off your audio so we don't have feedback. Okay, do you want to come up? Please, yeah, mute all your computers. Yeah, I can give you that QR code again. Are you on the right network? Maybe it's because you're using Arc. This is why you use Chrome, guys. You're in, yeah. I'm just going to be here looking for you all to raise your hand at any point, and I'll call on you. Matt, stage is yours.
All right, can you all hear me? Yeah. Great. Okay, let me get rid of this thing here. All right. Hello, everyone. Thank you for coming. How's everybody doing? Awesome. Cool. So I'm here to talk about GitKB. So I guess the story of GitKB is, well, I quit working at Tesla about 2 years ago because I knew that AI was going to change everything about software engineering, and I think probably everyone had that same anticipation. And I wanted to make sure that as this wave passed over our field of work, that I wasn't like bucked out of the wave pool. Hold, please. Dun, 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 dun. Boom. Looking good? Cool. Yeah, so probably, with the same anticipation that all of you have, because you're sitting in this room, I wanted to make sure that I was on the cutting edge of AI and riding that wave or being pulled along with some force by the wave at least, and not bucked out of the wave pool. And so I spent a lot of time working with frontier models and frontier tooling, but ran into a lot of the same problems that I think everyone who begins working with AI runs into. And I'm going to kind of give a background on why I made GitKB. And I'm going to pop over and I'm just going to fire off some commands because you got to wait on your agentic harness to do some stuff. And then I'll get back to explaining more of the story and the why and what GitKB is. Let's go with that right away. So I have cloned a OpenClaw repo here, and I have this command here, and I can type in either git-kb or git-kb because anything with git dash after it, Git treats like a plugin. But what is GitKB? Well, if you type GitKB, it'll tell you. And you can just go to gitkb.com, and there's a brew install. It takes 15 seconds to install it. So copy that, run the command, and you'll have this. But GitKB is a Git-like distributed knowledge graph protocol, okay? It has sparse sync and checkout semantics. So what does this mean? Well, you could probably describe Git in this way, that Git is a distributed graph protocol, but the graphs happen to help you negotiate like your branches and stuff like that. And Git is made for source control. You push and pull an entire repository of code. And that's the beauty, that when you pull it, you have the whole thing, and you fork the whole thing, and you just modify small diffs, right? GitKB is built for a different problem. It's built for expanding knowledge graphs, huge graphs of documents that grow over time to be eventually so big, the size of like the corpus of knowledge that the company Oracle has ever built, for instance, such that you wouldn't want to pull the entire thing. So what would something that works alongside Git look like that instead of solving source control problems, solving knowledge control problems instead, what would that tool look like? And that's why I built GitKB. So we have GitKB here, and to get started, you just say GitKB init, and that makes an empty knowledge base, okay? Well, now we want to use GitKB, and just like all tools, if you want to make your agent know how to use a tool that you have no idea how it works, but make the agent know how, you install some skills files. So from there, always dangerously skip permissions, we can come in here and say something along the lines of, we just joined the OpenClaw team as an engineer. Let's bootstrap GitKB to do some tasks. Okay. So we'll see in just a second. It's going to look at the default prompts and skills, and it's going to notice that there is nothing in this knowledge base. It's empty, and so it's going to say, aha, okay, so what we need to do is build up a corpus of context knowledge so that we can understand what it is that we're working on. In a way, GitKB is like an agentic memory system, in that instead of using ephemeral plans, which almost every harness forces you to do, it says, you know what, that's antithetical to our ability to maintain progress over a long period of time, or with a team. So instead of using ephemeral plans, let's start having structured knowledge, and that's going to build this graph of knowledge over time. But it starts by making a few documents at a time. And the first documents are these core context docs. And so GitKB is a protocol implemented by a binary. It's an 11 megabyte binary that has an embedded graph database. You don't have to install anything separate. You just run those 3 commands and boom. So with that all happening in the background, let's kind of recap. I just kind of gave you the whole presentation in a moment, but let me just give it to you. Sure. Yeah, I ran 3 commands. I ran brew install to pull the 11 megabyte binary. I ran gitkb init to just create a .kb folder with some special stuff in it. That's similar to a .git folder that also has some special stuff in it, okay? And then I did gitkb init Claude. You can do gitkb init codex, et cetera, and it installed skills files that told Claude how to use it, right? Okay, cool. So here's the presentation. Your agents start from 0, and there's probably like 100 of these presentations that start this way about tools online right now. But we all know this problem, right? You work on something, you got this like smooth groove going with the context that you built up, you're making some awesome features, you shut down your laptop, context compacts, the next day you start up again, and it's like, what are we building? I forgot. Okay, and so you got to go and spend, the first 2 hours of your day or something trying to get back up to that groove. This solves that. This makes it so the groove is creating over time and satisfied by this corpus of documents that you have built up. But it's more than that. So this is the problem, context loss, you have to recover, and it compounds. It's a real problem, especially for an organization, but even for individuals. This is what I call the ladder of context compromises. This is the series of steps everyone who begins to do agentic coding goes through. You first try your agentic harness for the first time, or you're using like Lovable and you one-shot it, blows your mind. You make a user interface. You go to implement the 5th feature and it deletes the first 3, and you're like, AI is garbage, I'll come back in 2 weeks. Then you start to learn how you can kind of structure your context files either in a directory or in a repository. Maybe you start using patterns like memory bank that it's like a skill file that tells the agent, like, your superpower is your amnesia. Make sure you structure your files. But you're using skills to do this. It's not declarative yet. And then you try and share that with your coworkers, and you're clobbering each other's context files. Or maybe you start to move away from that and you try MCP to integrate with like some black box on the other side of an API. But all these things are compromises. And GitKB says, this is not an unsolvable problem. It's similar to the problem of solving distributed source control. If we were to take the component aspects and the procedural aspects that Git does and rearrange those little building blocks and make another little binary for knowledge graphs instead of code, what would it look like? And that's GitKB. Okay, so GitKB is a distributed knowledge base with sparse sync and sparse checkout semantics. So that means that the context is persistent. We're saving it to files. It's not ephemeral. It's commit-based. And when you commit to it, there's a process that creates that basically projects the knowledge graph. So your canonical data is your markdown files, and the knowledge graph comes out of that. So the knowledge graph, if you wanted to, you could go and muck around with some data and blow it away. One command would recreate it extremely quickly. There's also code intelligence. So tree sitter is integrated into the protocol. And what I'll show you all in a bit is that not only does the knowledge graph have the ability to graph relationships between documents automatically, but it can understand the relationships between your code, because the entire graph of your code, the AST, is parsed, indexed, and put into this embedded database. Okay? All right, here's the big difference between Git and GitKB. Git is commit chains per repository. So every commit in the commit chain is effectively a snapshot of the entire repository. Now, Git is a graph database, but the graph semantics are there to help you do interesting things with branches. I rearrange that and say, well, what else can we get if we give up the branches and only have a single branch? Because knowledge never disappears. It just fades out into history on branches that don't grow new leaves, and you lose interest. So how could we use our graph semantics to better benefit us with knowledge? Well, that's to automatically generate and maintain the relationships between all your documents to create a web of knowledge that's easy to traverse and discover. So super easy to get working. GitKB init, GitKB code index will use tree sitter to index your code. It basically does a third of what a compiler does, all the fast stuff. If you were to build more, you'd have a language server, basically.
So we have a question from Ricky back.
Yeah. Yes. You use it with Git. Yeah. 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 Mm-hmm. So you're jumping to an advanced topic, but beyond just allowing multiple people work on branches, a single individual might want to have multiple agents concurrently working on many work trees, right? So GitKB is understands work trees, and if you think about the way that Git works, your files are not in the folder where you work. That's a projection of one branch within the canonical database. The canonical data is inside of .git in content addressable storage, and what you say is project, check out, project a single branch into a workspace where it will work. GitKB works the exact same way, but slightly inverted, where the canonical data is stored in a folder, and you say, project into this little hidden folder inside the .kb, and I'll project one for any particular work tree that an agent might be working on. So you can have multiple workspaces at any given point in time. So basically, we have a workspace concept, where the workspaces are one-to-one with work trees. Does that make sense? No. So GitKB is a new protocol implemented by a new binary, and it works as a companion to Git. Okay? What's that? Well, it's a distributed protocol, so it's both locally as well as remote. But the difference is that because we have commit chains per document instead of per repository, we don't have to push and pull the entire repository at once. I can pull a subset according to a path spec. I can pull a single document. Commit-wise, I will push and pull all commits that ever contributed to that document, or if the server has commits that are on a further position than my current head, it will negotiate and just get those commits. Or I could do a path spec, like a glob, and say, give me all incidents for, it would be like team/a/incident/star, GitKB pull that, and that would pull all the commits that represented those documents. Okay? Okay. Let's see. How am I doing on time?
We're good.
Cool.
You can ask. It's fine. You, the floor is yours. Go ahead.
Sure, hit me. So the data is not stored in Git. It's GitKB. It's a companion protocol to Git. Now, you could do something similar in Git, but there's reasons why you wouldn't, and I'll get to that in a bit. But just like Git is a distributed source control protocol, allowing you to share code files, GitKB is a distributed knowledge protocol. And so yes, it allows you to push and pull to a server. So user A could build up their knowledge base and make a bunch of documents and then push those to a remote server, and then user B or anyone else on their team could then pull those documents. Or team lead could build a bunch of specs for things that they want to build in their product, push those, and then a number of either agents or users could pull them and then implement them. It's up to you how you want to deploy it. You could have one knowledge base per project, or you could have a knowledge base for your company. Because it's infinite scale, because you no longer have to push and pull the entire repository. You can push and pull subsets of it. And so just imagine that like one subset is the billing org and all employees at the billing org, or marketing, and they push and pull all of their marketing documents, okay? Everything is a markdown document. So the beauty of Markdown, especially when you have this comment section at the front that's called front matter, and you're loading YAML into that, it gets hidden when you use a preview mode because it's inside of a comment, but that allows you to have structured data and then unstructured data combined, right? But in reality, it allows you to have structured data and semi-structured data. This wiki-link format is what Obsidian and other applications use, and it allows you to basically say, this is a link for traversing to another location within the knowledge base. And so you can see there's this parent and then this slug that represents the ID or a navigable human-readable ID of another document. So this is a child of that parent, but also you can see that these other document specs are listed in there as well, and even a code one. And so we'll get to that later, that you can parse out these relationships and build a graph from them. And that last one that we showed is that the wiki links can be more than just a navigable link between documents. It can be navigable links to other extensible things. And the first extensible thing that is built in is code intelligence. This is something like Source Graph Cody. This is a thing that enterprises pay like many thousands of dollars on a per-seat license basis for. And all of that type of functionality lives on a server. So you have to take the code and index it and ship it to a server, and it does code analysis. This will do it locally for free on your laptop. And so it's a part of the binary executing part of the protocol that uses tree sitter to index your code very quickly and create that knowledge graph that you can then use to traverse and reference within your documents. Yep.
So it sounds like at some point you might want to have a plugin so you can not use tree sitter for something. Tree sitter has some namespace.
It's not what? Well, Tracer, you can build all sorts of language files for parsing any number of languages you want, right? There's a whole DSL for it, so. And we support 17 languages right now, but the pattern's extensible, and this is not open source yet. We're getting things arranged so that we can open source it, and once it is, the pattern will be there for people to add additional languages. So yeah, so this is just kind of an example. You know, as you make more docs, the more connections, these wiki links, they get turned into graph edges, they begin to accumulate. And what ends up happening is you have this reinforcing, compounding set of domain knowledge that ends up being ready and persisted anytime your agent cold starts and wants to know, what are we working on, what's next, okay? So it allows spec-driven development at scale because, one, it takes you out of having ephemeral plans as a single user and makes it so you have this corpus of knowledge so you can start launching many different agents, especially if you're using multiple workspaces with multiple work trees. But it's also a knowledge graph protocol allowing push and pull. And so now you can scale this kind of like acceleration of spec-driven development to your entire team or your organization. And so you might ask, well, why wouldn't I just do this in Git? And you could, and I did, but what I ran into were a couple of things. People have different deployment models. People have like many repos or a mono repo, and even companies with a single mono repo, you often have additional repos as well. And so the question is, okay, where do the tasks and the specs and the architecture docs go? Should we be shoving these into the code and then we have to like yank them back out when we deploy? And there's a separation of concern issue that just makes things hairy, especially if you project that your company's gonna actually survive for a year and you're gonna have all these tasks accumulating over a long period of time. It gets a little rough. So Git is almost the right solution, but there are a couple of fundamental design patterns that are built into the Git protocol that make it not the right solution. And so that's why I really like to reiterate, I took the concepts of Git and I broke them apart and I rearranged them in a way that does solve this problem better. Now this GitKB does not solve source control. Git is better for that, and that's the intentional trade-offs. It's lightning fast. The vast majority of operations, even with many thousands of documents locally, are under 30 milliseconds. It can be used via MCP or CLI. There's more tests than that now, like many thousands more. And yeah, so let's see what it did. So over here, we are in Claude, and we're just gonna go back and kind of browse through. So we just kind of kicked things off and said, we just joined the OpenClaw team as an engineer, let's bootstrap GitKB. And because we installed those skills at the top, it understands how to create a document. So you can see it did GitKB create type brief. It's creating a project brief. And it gave it a navigable, human readable slug. It's like the human readable ID. And it's going to create these core ones. It needs to reread since making the file is just a Claude thing. But you can see that it made project brief, patterns, architecture, product tech, active, and progress. And then it began to populate it with this data. And so you can see these things have like these core meaningful intentions and purposes for the core project context. The skills drove Claude to do a code intelligence analysis of OpenClaw and then populate this. So these will inform our agentic harness the next time we spin it up and tell it what it's working on. So it will know, for instance, that OpenClaw is a personal AI assistant, right? So again, solving that problem of re-educating your harness the next time you spin up a new task, et cetera. Tech decisions, architecture, a product description, et cetera. But all of that is just kind of like the first bootstrapping. And so what we can do here is say, go to GH and figure out a simple issue we can solve in a task, create a task for it. Yeah. Not quite sure I understand the question. GitKB is a tool that can be used by anything. It's just a binary, right? So I can come and say GitKB and see all the commands, but I can do things like GitKB ls and see these documents that have been created by our process here. So we said GitKB ls, right? Mm-hmm. Yes, okay, got it. Well, let me just show. So everything is commit-based, and we have a single commit so far. Note that although the commits are chained per document, you can have multiple documents touch a single commit. But what that means is that when you pull that commit, it's going to pull related commits. And so it's kind of up to you. Do I want to push documents as a set or push a single document? But your question is, we're creating files. Where's the graph come from, right? Okay. All of these most likely don't refer to anything else. And so there's this GitKB graph command that will show you the graph relationships. But once we have a task, maybe we'll create one. Or what I can do is just come over here to my project and say GitKB ls and just pick some random thing. And I can say GitKB show, graph. And you can see that there are these relationships. And the relationships are more than just like references from one document to another. It's even like commits, right? GitKB ls. And I will answer your question, but I just want to kind of like show more of what the graph element might look like.
Matt?
Yes?
So 2 minutes.
Cool. So we're just committing and playing with markdown files on a commit basis, right? So it's the commit process that takes your markdown files and then passes that through an extractor framework that creates the relationships and generates them in the embedded database. So your canonical data is always the markdown files, and the graph database is emergent and extremely light and performant and can be thrown away and regenerated at a given point in time. No, no. 1 year ago, this started out as a completely prompt-based MVP, and I've replaced almost everything with declarative code that you get inside of a free 11 megabyte binary. Okay? And then on top of that, eventually, we'll also release this soon, which is, I mean, it works with there's a desktop app that's also free, so you can see the relationships. Like this is the set of relationships for this one task that I was working on yesterday or so. And you can see like it links to other documents. This shows documents that link back to this document, code that happens to be referred to inside of this document. This is a special wiki link somewhere around here, but you can click on it and it will even navigate you to GitHub and scroll down to the exact location where that code is. Yeah, so that's GitKB. Basically, it is a tool and a protocol for allowing you to do spec-driven development at scale, because it allows you locally to have a corpus of growing persistent knowledge, giving you, like overcoming the problems of ephemeral plans, but also giving you a push-pull sync protocol, allowing you to share this with your team. And yeah, that's GitKB.
One last question, Ramon?
So it's an entire implementation of a new protocol based on the way that Git works. And so there's push and pull. There is basically commit chain current head discovery. So everything that Git does, where the client says, "Here is my current head. Do you have that as head, or do you have something else as head? Did you have that previously within your commit chain? If so, then we're not totally out of sync. And if you have it previously, but that's not your head, can you tell me the list of commits that you should have to give me to bring me up to your head?" And then it sends down that chunk. Now, that's what Git does for a single commit chain for a single repo. If instead you move to a model where it's commit chains per document, instead what you're doing is saying, I have these sets of documents with these slugs, and this is all of their current heads. Do you have those matches? If not, what commits for each chain do you have? Send me all of those sets, and I will update head on all of my chains. Make sense? Again, it's the concepts of Git broken up, rearranged, and made into a new companion protocol. And it's free, so go to gitkb.com and please play with it. We're pumping out a new version all the time. And if you want help, I'm always on Discord, and I will help you. I'll even screen share with you, whatever you need. And that's it.
Thank you so much, Matt. Please give it up for him.
All right.
Steven? Do you want this one, or do you want one?
How about the
You need an adapter. It should be on the right side. There you go.
Hello? We're on.
Okay, everybody. We're still on. Good. All right. So hopefully I won't need this microphone because it's a small enough group. But anyway, I'm Steve. I'm your local neighborhood tech lawyer. We're going to talk about TRAIGA, and this is going to be nowhere near as exciting or technically cool a presentation. TRAIGA is the new, TRAIGA stands for Texas Responsible AI Governance Act, okay? So brief disclaimer, yes, I'm a lawyer. No,
Guys
I'm
in the
not
back.
your,
In the back, guys, Ricky, we can hear you. All right, sorry.
okay, brief disclaimer, yes, I'm a lawyer. No, I'm not your lawyer, and nothing here is legal advice. If you have anything cool that you want to talk to me about, if you want to ask me a question, please don't ask it in public because everybody will hear you. But if you want to ask a just generic question, I encourage those, and if you've seen me before, that's fantastic. Watch this not work. Come on, guys. All right, so what TRAIGA is about, very briefly, is the latest thing from the Texas Legislature. So the Texas decides that it wants to be pro-business and pro-AI, so naturally the legislature goes off and passes a law that says you can't do things while you're doing business or while you're developing or deploying AI. Thanks, guys. Okay, so I'm going to very briefly talk about what it covers, okay, why we have this law, who it applies to, which might be you, and how it will be enforced, which is hopefully not you. Okay. There are several things that TRAIGA says that basically the Texas Legislature wants you not to do, all right? You may have heard of some of these things before when people have talked about the European Union AI Act, and it's a very good indicator about the kinds of things people are afraid that might happen using AI systems. All right, first of all, AI systems are defined very broadly in the Act. So if you're doing something that you think is AI, it's almost certainly covered. Second of all, the kinds of things that the AI Act covers, there's a collection of things, and I will, there are directed against businesses. So if businesses would include people who build or deploy an AI system, okay, so that means all you engineers are off building something or planning to deploy it, you business people, that's you, okay? And doing a bunch of things which obviously the legislature thinks are bad. So the first one is people are afraid that your AI system will be used to manipulate people to do things that are harmful, typically self-harmful or harmful to other people, okay? Now, we've seen a couple of lawsuits that have been brought where people, where the family of someone who has unfortunately killed themselves has gone off and blamed the AI system, all right? This is kind of a special case of if you talk to a person who convinced you to kill yourself, that would be really bad. Well, it's considered just as bad if an AI system convinces you, whether AI systems are people, of course they're not, but dead people are dead people, and no one likes that. Similarly, if the AI system convinces you, or let's just say you become convinced after using it to go off and kill someone else or otherwise harm them, that's also a bad thing. Texas doesn't like that. And just for good measure, in that category, they threw in and if you do anything criminal because you were convinced by using an AI system, that's a bad thing too. So you're not supposed to do that. You would think this is like Ethics 101, but no, Texas has to have a law that says so. All right? The second group of things, and this is largely targeted at government agencies because this law, when it was originally drafted, was intended to regulate AI systems. And then the Texas Legislature decided that no, we're pro-business. So it ended up being mostly things that Texas government agencies can't do. All right? So, for example, illegal discrimination. This is discriminating against people based on certain protective categories. You all know what they are. I could go over the list. Or pretty much anything else that turns out to be an illegal category. So, you know, the usual: race, creed, color, national origin, you know, sex, sexual orientation, you know, hair color, whatever. Okay, all these things. And then third, the TRAIGA, again, targeting itself at government agencies, does not want people to build AI systems that go off and violate your constitutional rights. Okay, now, how an AI system might do this, I am not so sure, but nonetheless, it's there. A second class of things that TRAIGA says should not be done by AI systems, and this is entirely directed to governments, government agencies, okay? And government agencies includes things like city government, obviously, okay? So first of all, social scoring, all right? People have been watching what has been happening in China, and the whole idea of social scoring freaks people out, and so naturally, one of the things people are afraid of is that AI systems will go off and generate social scoring that says so-and-so uses his car too often and thus is not environmentally conscious, and so we're not going to include him in our bus system or whatever. Yes. It could be.
Do you know your social credit score? No?
Well, credit scores are not the same thing, but I do have
A social credit, like in China.
that's just the point
Yeah.
is that this is effectively prohibiting government agencies from creating social credit scores, and yes, that is very broadly defined. It's very broadly defined in the statute to say basically scoring any individual person or any group of people based on things they do or don't do, so as to later deprive them of some benefit that they might have. Generally, yes. I'm sorry, say that again.
Say China, it sounds like you agree with the Chinese government or disagree. It's part of their law.
Actually, what has been happening in China is they do things like, what has been happening in China is they do things like they say, oh, you paid your bills late, so now you can't buy airplane tickets, all right? So in fact, the government of China has been using this to crack down on people that they consider undesirable, and of course, anybody that the party doesn't like ends up being undesirable.
Yes, in the rear.
Yo.
That's basically the same as a credit score here in the US.
Yes and no. I mean, credit scores actually are much more regulated than you would guess. And credit scores are used almost entirely for lending you money. We decide whether or not to lend you money or not lend you money, all right? For example, and again, this is vaguely defined, unfortunately, but if I were to keep a credit score and a social credit score and say, okay, I'm not going to let you buy, a parking permit because, you have too many traffic tickets or whatever, that would probably qualify. Yes.
At least we couldn't get a job without getting like a credit report. Like it's required them, like the credit scores they were in check for jobs.
I've never seen anyone get denied a job for a bad credit report. If that started happening, I imagine people would get upset. Bear in mind that this covers AI systems which do that. So if you do it without an AI system, I suppose you won't come under TRAIGA. Yeah. Because that was what the legislature decided to work on today. They figured, this is our thing, we're going to regulate AI, and they came up with these bright ideas. This is one of the big ones.
So if-else statements are fair game. All right, go on.
Yeah, well, effectively, you can think of this as the legislature is saying that no, having a social scoring system is itself a harm, and they don't want that happening. This law regulates AI systems that are built or deployed and which affect Texas residents, Texas consumers, and the like. Okay, so if you were a Texas government agency and you were to build a score like that, I mean, let's suppose the Texas equivalent of CPS in Austin were to do that, and then this law might potentially apply. Maybe, maybe. I mean, it waits for somebody to see, but you know, that sounds, it's very broadly drawn, so conceivably it would. Yes. No, there's no real distinction. I mean, the thing is that AI systems are, the statute refers to AI systems as pretty much any system that takes inputs and goes and manipulates them and generates an output, you know, and then of course, you know, some human being has to look at that output, but if some person, you know, picks up the output and then follows it routinely, then almost certainly that AI system and its builders and developers and deployers are going to get blamed for it. No, it's not specific to LLMs. You know, as I read the statute, you know, any rule-based system like an expert system would undoubtedly qualify. Okay, the statute gives a definition which effectively says if you take inputs and you manipulate them and you come up with an output, and yeah, I know, it sounds very much like it could be a spreadsheet, but then since they say we're defining an AI system, then AI system is probably going to have to look like an AI system. You know, it could be a language model, but it could be something else. Yeah.
Sure.
Okay, first of all, healthcare itself is actually, there are certain healthcare features which are exempted because healthcare is, as it turns out, fairly strongly regulated already at the federal level. And so, for example, if you maintain your data you know, according to HIPAA standards, the statute actually excludes that and excludes a variety of other things like, you know, like if you are an agency that runs a hospital or something like that. I should probably take the details on this. I cannot say that I'm going to give you really good details because this is a relatively new act. It came into force in on January 1 of this year, and I do not know of any cases that have happened such yet. Defining, understanding, explaining what that means. Yes. No. The biometric data part is basically involved. What is prohibited is collecting biometric data and then assigning them or associating them to individuals using AI. I'm pretty sure that if you simply collected people's fingerprints because you had them physically there, that would not be this issue.
Ricky.
It could easily apply to insurance. If you're a government agency and you're deciding whether or not, again, remember, there's going to be some limitation here, and this section is applying to government agencies. If you're a private insurer, I mean, if the private insurer says, you know, well, if you have these extra cool brakes on your car, we will charge you less for auto insurance. As far as I can tell, they'll probably be able to do that. Remember, this is a new law. The definitions are fuzzy. They haven't been explained by anybody. No court has treated them yet. It's a mess.
Who here wants to create case studies? I'm just kidding.
Yeah, that's
Steve,
right.
how are we on the position of slides? So we're like 10 minutes out before I take any more questions.
I have a lot more slides.
Okay, we'll
But
just
they're
hold
quick.
off for a bit. Yeah.
But they're quick, hopefully. Okay, come on. There we go. Other things you can't build. All right. once again, what people are afraid of tends to show up, okay? There is a section that essentially says, okay, no, we don't want to see deepfakes. We don't want to, if you're building an AI system that creates them or manipulates them, this is bad. Obviously, the legislature doesn't like child pornography, okay, which goes off and they refer to the section of the criminal statute that refers to child pornography. This is bad. And then finally, there is an additional section which prohibits text-based conversations that are explicit and in which one person is pretending to be a minor. Okay, now, my first question when I saw that is, it looks to me like the police do that all the time, and yet here we have a statute that says governments can't do that. My guess is that there's going to be written into this either by court opinion or by the legislature fixing it that yes, this is they're for the purpose of catching people who are criminals. This is a bad thing, but if you're doing this as a private party, you're a business that does this or you supply this, this is going to be very bad news. Okay. Again, this applies in Texas because Texas obviously can't regulate behavior in New York or Florida or California or whatever. Okay, so it will almost certainly apply if you are running a business and your users are Texas residents, or if you market or you advertise in Texas. Okay, or if you're basically you're a B2C, if you're a B2C business, okay, or if you're B2G, which means business selling to government, and the government agency then proceeds to use it. It probably does not apply if you're doing things which are just straight out business to business, or a variety of other things that also relate entirely to businesses. And then there is a collection of things which are regulated by other means, such as financial products, or universities, or hospitals, which are exempted. Okay, once again, this was initiated because the legislature thought, well, we're going to go regulate AI, aren't we clever? Okay, other states are doing that, so let's join this bandwagon. But eventually they changed their minds, and now it's supposed to protect consumers and control government agencies. Yeah. Okay, there was a bill that was passed last year by the federal government. Remember the one big beautiful bill that the president wanted to have passed? There was a clause in that bill that was going to prohibit states from regulating AI systems for a period of 10 years. That was not passed. It did not make it into the final bill. It was not enacted, okay? But bear in mind that the federal government could go off and make this the rule in the future and wipe out state rules, okay? Or various federal agencies have their own rules. Like, for example, Health and Human Services has HIPAA regulations which regulate medical data. Gentleman back there, did you have a question or were you stretching? That's you. Okay.
Did you still have a question?
Go ahead. Quite possibly that will get regulated by this. Facial recognition. Yeah, but facial recognition is to ask who you are. Right. It will depend, ultimately this is going to go to some court which is going to say, yes, this looks like this is what the statute was intended to cover. It's unlikely that this statute will be held unconstitutional. What is more likely is that some court will look at a particular section of it and say, this is what the legislature really meant, and you fall within it or you don't fall within it. And we'll have to see when that happens. I'm sorry, explain that a bit. that's going to apply to the government entity that uses the tool. Okay, and okay, now one of the interesting ways that this law was restricted is that originally it was designed to cover AI systems that do bad thing X, bad thing Y, bad thing Z, but in fact it has now been written to say that you intended for it to do bad thing X or bad thing Y or bad thing Z. And if some government agency goes off and buys a standard system, which you had no idea how it was going to get used, and they use it for some terrible purpose that turns out to be a bad purpose, then you don't get dinged with that. You do get dinged with it. The government agency will get dinged with it, but the company that builds or develops that system will not. There's a weird enforcement mechanism for this. There is no private opportunity. We call this a private right of action. There's no opportunity for individuals to sue, to complain on this. Only the Attorney General can. So the Texas Attorney General, so we all get to listen to Ken Paxton and whether or not he likes your system or not.
Time to make a new friend.
Yeah, I
But
know.
so
Exactly.
three minutes, by the way.
In addition to that, okay, so what happens is that if there is a consumer complaint, the Attorney General can go off and complain and file a lawsuit based on that. There are two interesting features for enforcement, one of which appears on this slide, which is there's actually a curing period. So if you build and develop a system and the Attorney General thinks, you did something that your system does something it should not do, you have an opportunity to fix it. There are fines which can be imposed. Obviously, after that lawsuit gets filed and you don't cure your system and the court finds that you did something that you should not be doing, fines can be up to $200,000, and the AG can ask the state agency, if there is a state agency involved, to further enforce the law against you, such as by, if you have a license to practice, that they say you can only do this. If you have a license, they can actually lift it. I was going to compare this with the EU AI Act. I think I have some time problems, though, especially since I have more slides. But there, obviously, social scoring is something that has raised a lot of interest. Deep fakes have raised a lot of interest. And as you can see, this shows up in the statute as the kind of thing that people care about. Another interesting thing about the statute, first of all, explicitly says because it covers intentionally building systems that do things that the legislature does not want you to do, you can, for example, engage in making a record that says when we build our system, we are intending to do A, B, C, and we are not building it to do bad things, X, Y, Z. There is a known risk management framework, which comes from NIST, the National Institute of Standards and Technology. The NIST risk management framework on AI, if one follows that, and then untoward things happen that you didn't deliberately plan for, that will probably be okay. The statute also has another weird feature which I have not seen before, which is that there is a sandbox provision. You can go and apply to the AG, and if you get approval, you can build your AI system, and it will get a 36-month exemption from